I have my small.
You have your small. Please, I'm saying that get yourself a better network. Get yourself a better network because this is not working. Okay, next week, don't talk like this again. Because the way you're talking right now is funny. Eh? It's okay. It's okay. Got told. Cut it. Just mute. I have to mute this.
I've realized. So, hello, I've realized that people.
Got told. Just hold. Just I can't even mute you. So just. All right. So please see the disadvantage of organizations not using GIS. This is what happens when people connect. They don't have good service, and then now they are talking funny like the way God told is going about it. So a lot of organizations should implement GIS properly so that they will become more efficient in what they do. Is that okay? So the location of masts is one of the things that telecommunication companies should be looking at. And there's a lot that I hear they look at what they call the Fresnel zone, and then they before they even consider even where to place it and all that. So interesting. We can just keep going on and on and on and on. So the digitizer allows you to do a transformation of information from the analog means hard copy, okay, or not digital. Anything that's not digital is analog. So we can have a paper map, it's hard copy analog, and we can now click on it, click, and convert into a computer. So the digitizing board is connected to a computer, and you click along it, like the lady is doing up here. Okay, all right, so going back up there, we have 3 modes when you do digitizing. You have the point mode, you have the stream mode, and you have the on-screen digitizing. Okay, so the point mode is where you just select points as you wish, okay, to define the geomorphology, the shape of the geographical object. Then the stream mode is where you allow the computer to select, record the coordinates within a certain time interval. So you just move your mouse along, say, a very long road section. And then the computer every now and then it records the coordinates. In that case, then you don't have to be clicking all the time. So that's the advantage of the stream mode. The on-screen digitizing is when we do digitizing on your computer. So we may do that practical as well. I think we may do that. All right, so that's it. When you do all these digitizing, converting hard copy into the computer, you are bound to make mistakes or to come out errors. So one of the common errors is, are undershoot and overshoot. Okay, so we are looking at if you have an undershoot, then you have to extend, okay, or snap. Then if you have an overshoot, they need to cut it or trim it, okay. So that is what you see on that side as well. Okay, so when you are digitizing, there are a few rules. Okay, you can just take your time and read through this. You ask questions. Okay, what am I digitizing? For what purpose am I doing it for? What coordinate system am I digitizing for? We'll talk about coordinate systems. Okay, coordinate systems are very important. Once you're dealing with coordinates, we can have, at least rectangular coordinates, polar coordinates. You can, those things are mass type of coordinate system, but you can actually look at coordinate systems as used in GIS. Then we are looking at, universal transverse Mercator. We can look at other geographical coordinate system like World GIS 84, World Geodetic System 84. You should look at the accuracies and you should digitize as much as you can, because you can get bored of the digitizing and start making mistakes. Okay. And you need to also consider if there are several maps to be digitized. Okay. One person should be digitizing at a time, not okay, someone does it, the other person can, hey, let me just try it. You don't do that. So for consistency's sake, is that okay? All right. And you should consider using common reference points between different sheets of paper. If you have, you see, because the world, we are now in the digital information age, and it's not too long since we left, the age where there were no computers. That is where this digitizing comes in. All right. But a sister to a digitizer is actually the scanner. So this is what you're looking at right now. So the scanner does something slightly different from the digitizer. So the digitizer is giving you points, coordinates, okay, to define the object, whilst a scanner is giving you a screenshot. Are you okay? All right. So when you take a document and you scan it, what you get is a picture. So you can get a JPEG or you can get a PDF from it. All right. So here, different paper sizes can be scanned, as you can see in these four, pictures. All right. So basically, that's that. You can also talk about. So then again, you see the word raster showing up in this corner. Okay. So the raster is really referring to GIS data model. We talk about it again. Okay. People don't listen. In exam, I also have data model. Someone will be writing about, fashion models. Please. The raster model is made up of pictures. The concept of capturing data in the grid, square grids, yeah, capturing data over an area by actually dividing it up into squares. That is called a raster model. Are you okay? And so every picture is made up of picture elements. We'll talk about this again. But once you scan, that's what you get. It's okay. We can also talk about the plotter. So here on the right hand side, we have a plotter. So a plotter is a printer, but it's actually a large format. Format means dimension, a large format printer. So you can plot A0, A1, things like that. It's not even common to find A3 printers around. Are you with me? So we're talking about hardware of GIS. Put it to your mind. That's what we're talking about here. All right. Let's not go off. So I think I've already talked about software and compatibility, updatability. I think these are things that probably these three were not even touched on. Compatibility, updatability. Every good software should be compatible. It doesn't just run just on one machine, it should run on other machines. It should be updatable. So we do get updates on our phones. And remember that the phones we are using now are computers in disguise. Okay. All right. Now GIS software, there are so many of them. Okay. But you can talk about GIS is so popular that I don't know, people just can't. They have Mapinfo. Okay. We have QGIS. We'll be using QGIS in this class. Part1 GIS. Okay, we'll be using this one. Then there are web GIS. Web GIS. There are so many of them. Anytime you go on Google Maps, example, then you should know that you are actually dealing with a GIS software, but it's not installed on a computer. It's actually working on the cloud. Okay, so please, when I say the cloud, I believe you know what I'm talking about. Okay, so that is basically the components of GIS. I just keep touching on it. Data is so important. Remember, we haven't talked about data. All right. Data is so important that I just don't know what to say. People make money from just generating data, whether you will use it in your GIS or not, and they'll make money. Let's look at when Ghana actually subscribed to use to create, okay, some sort of address system. or address information system in the form of Ghana Post GPS. We all know, the brouhaha and then the sort of controversy, and discussions that really came up. And one of them was that it's so expensive. Why are we paying millions over, millions of dollars or thousands of dollars over a year? In fact, it was close to $1 million. I think that's what I'm tempted to say that. And why not? Because when they were collecting the data, you were not there. Can you collect it yourself? No, you were busy doing something else, isn't it? Making money and in a certain way. So guys, we need to recognize that data is critical, it's central, it's almost the main thing. Once you have, if I want to do a project in GIS, once you have your data, you are fixed, you are good to go. You are good to go. All you need is the data. You don't need anything more than that. But data, what is data? What is data? Data is a raw fact. Okay, symbols, alphabets, numbers, that's data. Really. So if I send you 2 pairs of numbers right now, it's enough for me to get into trouble. Why? Because I could be sending you my longitude and latitude. That's called information now. That's then the pieces of data in there are what? The longitude and the latitude, which are numbers. I hope you are getting this. Please, you need to get it because these people are not scoring high marks when I ask them questions. So follow the thing very well and understand it because it means it's not as easy as I'm making it look. All right. So that is the data. You need to collect the data. Are you okay? So let me tell you, I just want to show you what we are paying for. We paid so much for as a country. So this is Ghana Post GPS website. And for the map to show up like this, we had to pay every year as a country. And it wasn't a small amount. Every time people use it, then the country is paying. You see? They've written a whole lot in the high purchase in Ghana. Which place is this? I think probably I should zoom to this place with the wage or something like that. So now this is GIS for you. What you are looking at is GIS. But what are we paying for? It's not the website that we were concerned about. You could just pay $10 and host this website. The main issue was the data, or is the data. See all the buildings showing up in the background right now. That is where our concern was as a country. That we have to pay a company called Google, which is not in Africa, nowhere near West Africa, somewhere out there. We had to pay them. Okay, and when you hear the amount, you just can't even you can't believe it. And we had to pay for it, and people were so concerned. So data is so important, and we should recognize that the collection, I think, is the amount of time and money spent in data collection. That's what makes it so expensive. Okay, I had to charge my laptop. Okay, I think it's charging there. All right. I'm trying to look for AIT here. It's not coming up. Accra is teach technology. Okay, not coming up. You're not on their database. So you see, all this has to be collected. The university is not on this database. It means someone has to update it, etc. So, but basically, that is what data is. That is what data means to us. As you guys, without the data, the whole system is totally useless. Without the people, the whole system is useless. Are you okay? But data is our focus right now. Are you okay? You buy it or you create it. There's no 2 ways. If as a country you can't collect your own data, geographic data, forget it. Someone's father will collect it and they will charge you for it. Are you okay? All right. Now there's something interesting about data, that data can be measured. Are you okay? Data is actually associated. There are different types of data. Are you okay? Or data attributes. can talk about data attributes, properties of data, more or less. Okay. Now, so we can collect data which are integers. We can collect data which are place names. Okay. We can collect data which are actually like the differences make different. The intervals make a difference. Okay. The differences make. Am I hungry or something? I'm beginning to cut. So the different types of data attributes. We can talk about nominal data. We can talk about all right, someone is trying to call me on my phone. So nominal data means data in which the names are of essence. They help you to distinguish one thing from the other. So nominal, N-O-M, nom in French, that means name. Are you okay? So data like Wager, Bawe, Accra, Ivory Coast, are you okay? London, Ontario, all that kind of data is called nominal data. Okay, you can keep saying it, but I've heard comedians use it in the rhyme. Are you okay? Like ordinal data is also about data in which the classes, there's a classification. Example is road classes. So as civil engineers, we know it that every road has a class A, class B, class C, and it tells, it's a way of distinguishing between one road and the other. Is that not so? All right, so in that case, we have ordinal data. We can have what we call the interval or ratio data. In that case, we deal with temperature. Are you okay? So if the temperature means anything to the project, the data you collect on the particular object or entity can be interval or ratio. Is that okay? So interval data is data in which the differences between the values make sense. Are you okay? In other words, twice a particular temperature, say 2 degrees, 4 degrees, 2 degrees. Which one do you want? Okay, I want 4 degrees because 2 degrees is too cold. Are you okay? That means the interval is making a difference. Meanwhile, we have what we call the ratio data. So ratio data is data in which the lights off, I hope not. Ratio data is data in which we have an absolute zero. Is that okay? So weight is an example. But you see, 0 degrees Celsius it's not the same as 0 kilograms. The difference is this. 0 kilograms means that there's nothing. There's no matter. Matter is anything that has weight and occupies space, right? Now we're not having the weight happening, so there's nothing. But let's look at temperature. 0 degrees Celsius doesn't mean there's no warmness or coldness. There is. Okay, which means that minus 26 degrees Celsius means something to someone in another part of the world. Are you okay? All right, so that is where it comes in. When you go to the bank, someone's balance is actually negative 2,000. So in that case, 0, you're better off. 0 is not 0 then. Okay, so that's a basic difference between the two. Okay, so here we see example, stock exchange. What do you think? Is a stock exchange ordinal, interval, ratio? Okay, or nominal, ordinal, ratio, interval. Okay, or can we look at other things? Is it absolute? Are you okay? Is it nominal? Is it ordinal? So you can use that trick to also find out what it is. Okay, so if you don't know what a stock exchange is about, I think that is where we need to explain to you what it is. Stock exchange, that's where they do the exchange in terms of they sell stocks, like a company shares and stuff like that. Okay, so let's move on. As a homework, go and look at it. So the people in GIS make up everything. Those who are creating the system for you, those who are using the system, they are all part of it. Okay, GIS just range from technical specialists who design and maintain the system to those who use it to help them to perform that. Sometimes you have those who are even developing it, and then you have those who actually can use it. Okay, there are two different people altogether. And so that is, we talk about the brainware. Talk about software, hardware, brainware. You've gone to buy your software, buy your hardware. Where is your brainware? So you don't have anybody who is good enough to use the software to your advantage. Okay, so I think we talked about methods, but I put this burger here. Don't start feeling hungry because I put this here. But there's a reason for this. The reason for this is that this is KFC, isn't it? Yeah? Or Burger King. I think it's probably either Burger King or KFC. But you realize that the business, I was told, there's a book that I read that said that the burger wasn't the idea. The idea was to acquire real estate. So you see the business rule in this case. So he's not interested in it, but he knew that people like to eat a lot. So it was used to now locate properties. I mean, honestly speaking, this is like someone's secret, but every business has some kind of way that it operates. In other words, Uber, we can all start our own Uber business. Nobody can stop us. But they are the first entrance into the business. I'm not really talking about business here. I'm talking about methods. Okay, methods. The method is how you want to solve a problem. Business is about, problem solving. So please, if you have a question on what I've just talked about, which we started last week, these are all components of GIS. You can ask. You are not taught for exam. You are taught so that you can learn one thing. Do you have any question for me? Any question from the class, or are we good? Okay, so when I ask you a question, don't write anything. Don't go Googling and getting some funny thing for me. That's what people have been doing. It's okay. Those who be doing online exam, please. It's better you write things that you are seeing on this screen for me than you go Google and give me something that is totally out of place. It's happening. I wouldn't be saying this, but it's happening. And I don't think I'm liking it, so I have to say it. When you Google, you get a whole lot of, excuse me, say nonsense coming up. Sorry about that. Okay, so if I'm still sharing this one, you should be seeing metadata on the board. Metadata. So I've dropped a few questions on metadata in exams. And a few people got it. Other people went and they Googled, and then metadata was coming up in Google results, which were totally wrong. Okay, so the metadata is really data about data. But the way I've presented it is the best way to put it. Otherwise, any other thing you see out there may not be what I want. Anything you see out there, you Google and you get something on data quality information, I will like, it's okay. If you get something on identification information when you Google, great. When you get something on entity and attribute information, good. Apart from that, anything else you are getting as a Google result is wrong. So when you are getting answers, for example, let's look at that. All right. So data about data, metadata, or data about data is intended to provide sufficient information that a potential user of the data can make an informed decision about the application and use of the data set. So what does this mean? What this means is that before I buy, I would like to know what I'm buying. I mean, it's like simple as that. Are you okay? So I would like to know, for example, the data who created it, when was it created? Are you okay? The lineage. Lineage means tell me when maybe it was created in 1960 and then reprocessed in 1990 and then 2000. I need to know. There's a whole lot of things out there. All right, logical consistency. The data should have those information associated with it. That okay, this one relates to this one that way. Maybe I'm collecting data on speed limits. Okay, so the speed limits relate to maybe for class A roads only, something like that. That consistency has to be there. Completeness of the data should tell me that okay, this data set is lacking data on particular routes where national security, like it's an example I'm giving to you, that if the data is lacking, then we need to find that in the completeness information. Are you okay? Identification information should now tell me the intended use of the data sets and on any known limitations, so that we can know that this is the kind of data that you are putting your hand on. Are you okay? That this is it. Please don't use this data because this data is for students only. That is identification information. So then there's a need for citation on and documentation regarding the data. Okay, so if we are collecting data on, say, soil moisture, taking samples and plotting them with GPS, can you imagine that that is a possibility? Okay, so I'm coming out with my next question for you. I may not repeat questions the next time. It happens sometimes we repeat questions. We have to sometimes. Entity and attribute information should also be part of metadata. All right, so entity and attribute information, let me tell you what it's about. The entity is the object, the attribute is like the property. So we can take something like a building. A building becomes the entity, and the attribute of the building then will be the average height of the building or the height of the building. So that's a typical example of entity and attribute. And he's saying that we need to get to know the range of known or permitted values that can be stored. So when we talk about height of a building, you put 200 kilometers. I mean, hello, everybody's going to go like, what is going on here? And so therefore, you need to support that data with the source of definitions and attributes. I give you a typical metadata here. So normally metadata comes along with the actual data in soft copy or soft, version, a sub version of it. Okay. So you get something like a shape file. Shape file is one of the most popular file formats in GIS. And then the shape file now will come with an XML. So that is what I'm showing you on the board right now. I've opened up that XML. And so the machine reads the XML. In other words, your software will read this. And then it will display it, and then you'll be seeing it nicely that this data is supposed to be used for this. It's not. It was created by this company and all that. So when you look closely at what we have on the board, then you can see that I have the origin of the data is the Environmental Systems Research Institute, ESRI, the company that actually created ArcGIS software. Then it was published, this data set was published on January 2001. Then it says publication time, we don't know. So they are telling you, all right, so it's up to you to decide. They don't know the publication time. Would I use this data? So that is the idea and the rationale behind metadata. Vector digital data, it means the data you are holding is not raster. So it's not a picture. It's not a satellite image. Are you okay? Etc. Then it's now telling you exactly what the data is about. Look down there. It says the data is a simulated data set. What does it mean? It means anything that's simulated means it's not real. Are you okay? It's not real. It was created for instructional use. So it's for teaching in school. So you go and take this data, you start going on the media to make some declarations. Okay, I'm not talking about election petition here, and declarations. Yeah, it's very interesting trends in Ghana at the moment. It's all right. The data is produced for users so of course all this is supposed to help the user, potential user. They haven't used the data, but they need to know before they actually do that. All right, so that is basically metadata for you. And our next topic is topology, but you can ask me questions on metadata since it's a topic. If you don't ask a question, it means you are good. All right, what time is it? We are finishing. It's 2:45. So we are going all the way to within 2 hours solid. So that will be 1:30 to the 3:30. We are done. So we have like 30 minutes and a bit. Then we are done, please. But you can ask questions on metadata. We are not in a hurry to go anywhere. If you have a question, ask me now. If you go in exam and I ask you and write something else, I won't be happy with you. Normally, you give people marks because you're so mad at them. Okay. Am I even permitted to say that? If you have a question on metadata, this is your chance to ask it. The next time you see somewhere, if it ever comes into the exam. Yeah, okay, let's move on. I'm going to talk about something else. Topology, of course, I'll probably give you an assignment or something like that for you. Topology is not really about boys and girls. I just put it there so that those who are sleeping will wake up. Sometimes we're teaching a large class and people are sleeping. They see a man and a woman like this and they are very excited, isn't it? So, but then the whole idea is that topology is about relationships. It's about relationships. So this is a relationship that's gone bad. Are you okay? But the relationship is not about human beings, it's about relationship between coverage features. I always say coverage features, then we are talking about, you know, the objects that have been captured into our system. We can call them features, basically. So coverage features is a way of describing the objects. All right, so the relationship is between lines, arcs, nodes, polygons, okay, all that is coverage is part of it. So that this coverage features is actually a term used by ESRI, ESRI, ArcGIS. Okay, right. Topology. So what is it? It's not topography. So if you go and write topography, it means you are not part of the lecture. And so this is how I determine those who pay attention during the lecture. Topology refers to the spatial relationships between geographic features. Okay? Topology refers to a spatial relation between geographic features. It describes the relationship between connecting or adjacent coverage features. So a feature, like I said, trees, I even mentioned trees, like we're talking about roads, buildings, football parks, green spaces, that's coverage features. All right. GIS that supports topology allows a set of topology rules. In other words, every relationship should have a set of relationship, isn't it? Rules, every relationship. So, sweetheart, we don't do this. It's okay. Please don't say this word whilst we are in this relationship. These are rules. Okay. The same way, topology is supported by rules, and one of them is that you can't have one feature overlapping the other. That can be a rule in topology. Is that okay? So every GIS that supports topology will allow you to set a rule for how the features or coverage features relate. Are you okay? And normally you apply these rules after you've done the data collection and you have these errors coming up. For example, after digitizing, you have one road not reaching the other, one road crossing when they are not supposed to cross, and a whole lot. When you have a road, a crossroad, not an interchange, are you okay? A crossroad, and then one road is supposed to actually meet the other and it's not meeting it at the junction. All those things become part of topology.
Hello, sir.
Yes.
So does it mean that, if I understood you well, does it mean that it's go with the landscape based on your explanation?
I didn't mention the word I didn't mention the word landscape. So
no,
I had to mention the word that I used. Yeah.
Based on what you are explaining.
Mm-hmm.
The intersecting of the roads and all that.
I don't get you.
Does it related to the intersection of the roads?
Does it relate to the intersection of roads?
Yes.
Yes, when you have an intersection, think about intercourse. Are you okay?
Okay.
I hope you get what I'm saying. So in a relationship, in a marriage, for example, the man and the woman, they have, there's a better word than intercourse. I think, how do they call it? The lawyers have a word for it. Consummation. Are you okay? That is the relationship. So if two people marry and they never have consummation, the marriage is null and void. There's no relationship. Are you with me? The same way topology applies to, so you are right. It applies to how we represent. The keyword is represent. So GIS is happening on the computer. But then it relates to the ground. So when we represent two roads, or if we represent the intersection at Kaswa or the one at Malam on paper, then you realize that we are having the Accra road going this way and then those going to, so this is from Accra and then this is going to Winneba. Okay, this is Accra, from Accra, this is Winneba. Okay, great. So at this point, you see that there is no obstruction, those coming from this part, there's no obstruction. So there's no interaction between those coming from Accra and those coming from Medina. So this is, those coming from Accra actually this way. Okay. And those from Medina are actually from here. They never have any interaction at the junction. The interaction is the relationship. So the interaction between, or the relationship between geographic features, it's actually, it can be related on the ground and represented on the computer. So the representation in the computer is where the topology comes in. I'll show you what used to be the case. What used to be the case is that those coming from Medina now have to contend with those coming from, are you okay, Accra, whether in a roundabout or in a simple crossroad situation. Then you have to wait for those coming from Accra to pass before you now join. And so it created traffic. Pay attention to what I'm saying, all of you. And so that traffic, now everybody realized that, Charlie, we need something called an interchange. No, the transport expert said that, but even people living around knew that what we needed was an interchange. The same thing happened at Kaswa. So now this one becomes a no-no. Nobody wants this. Everybody wants a situation where we are not having any interaction. But now in topology, we start representing this. The reason why we do topology, let me tell you, one of the reasons is that we want to do what we call network analysis. So we want to find out the flow. Okay, if we block this road, what will happen? And all that simulation and all that analysis can be done when you use a GIS. Sometimes I get too, I don't know what I'm saying, passionate about what I'm talking about.
Okay, sir, can I come in?
Are you getting what I'm saying? Somehow.
Yeah. Can I chip in a bit?
Chip in, feel free.
Yes.